Very good morning. Quite fast. We are already in week 8 now. Students, how are you all? I really believe that you all are well. You're taking care of yourselves very well according to the standard operating procedures of being outside. And I just miss you all from seeing you all physically. Of course, I have some of your names in my mind when I'm meeting you all in the Zoom for tutorials. But for the rest of you, send my regards. Take care of yourselves. And let's welcome. We'll move into week 8 lecture. This week, we are analyzing one of the two option pricing methods. Today, we are going to analyze or explore into the binomial model. Binomial model is actually to identify the option price, which I mean the option premium. Using a binomial model, we also some books call it as binomial tree. Let us explore now. Objectives of this lecture and the outline of this lecture is only very simple. Be able to explain and apply two binomial models to price options here. That is, one is no arbitrage approach. Remember this very well. It's going to go throughout this chapter. No arbitrage approach. The number two is risk neutral valuation approach. Not much of difference between these two, but you can see the approach, the workings are different. And second objective is to apply binomial model to multi-periods. When you have a little medium term kind of an expiry for the option, let's say 6 months option, but you have got the interest rates calculated for 3 months. So there are 3 months in 6 months. So we'll break it up into period 1, the first 3 months, period 2 as the second 3 months. And that can be continuous. But the basic thing is if you can calculate and you know how to apply for the first one period approach, then the same thing can be replicated to many periods. It's not a difficult thing. Let us see one by one. Okay, the binomial model option pricing itself has been researched very well by Cross, Rose, Rubinstein, and all these people. but very important thing you have to take into mind here is, despite its deceptively simple assumption, the model is extremely versatile, able to price many types of options such as American options, which the Black-Scholes method model cannot do. So the binomial model is simple and easy to use for almost all type of options, all styles of options, American options and European options. But the problem is there is a kind of a judgment on this that it is discrete. It is from one time to another. It's not continuous. So usually option pricing should not be having gaps, but in this, no choice that it is jumping either one step up or one step down. There's only two possibilities. We are counting it on two possibilities. We are looking at the probabilities of it going up or probabilities of it going down. If it's a call option, there is a value of going up, zero value when it's going down. If it's a put option, then there is value when it's going down. There is no value when it's going up. Okay, let us structure it carefully and see based on these two models which we're going to discuss today. Okay, let us start off with a simple binomial model first. Once you understand the simple binomial model, it's easy to apply for various different periods and various different styles of the models. See, assuming that S0, stock price currently is $20. That's where the starting is of the branch. Okay, stock price today is $20. We don't know the value. When I say the value or the price, it is equivalent to the premium. Don't get mixed up. Sometimes I may say the value. Sometimes I may say the premium. Sometimes I may say the price. Okay, all are same. Okay, we are taking it for a one period of 3 months. In 3 months' time, there is a possibilities of the stock going up to $22. There is a possibility of this stock coming down to $18. So when we fraction out 22 divided by 20 today, it is 1.1. There's a 10% chance of it going up. I'm talking about 10% chance, not a probability. It is 1.1. That means 22 times 1.1, 20 times 1.1 becomes 22. So there's a chance that it might go up to $22 in 3 months, or there is a chance of 0.9, that is 18 divided by 20, it becomes 0.9, down chance of it becoming $18. So look at it carefully. Going back to the profit function of a call option. Profit function of a call option, you have got positive intrinsic value only if the price goes up, where the ST is $22 here, okay, minus K, we don't have the K here yet, that will give you the value at the time. Here, of course, when it goes down for a call option, it will have a zero value automatically. Let us see. Okay, we go into a call option. A 3-month call option on a stock has a strike price of $21. Going back to our initial example, the stock price today is 20. You don't know the option value today. That is what you're going to find. Okay, there's option pricing here. So 1.1 is the up value where it goes to $22. Because the strike price is 21, ST minus K, the value is, the option value today is $1. After 3 months is $1. If it goes down, the ST is 18. Minus K, it will give you a negative value, and you cannot add up any negative value in option call option. The function is that most lowest it can go is 0. There's no value there. So call option, there's a value where ST is $22, K is 21, so the value is, intrinsic value is $1. That is after 3 months. Now, of course, once you calculate this, you have to discount it back to today. What is the value when it's $20? That is our function here. Okay. Now, let us see the first approach. No arbitrage approach. No arbitrage means there's no chance of price being different from what it's supposed to be. The idea is, since options and underlying assets, let's say a stock, are related by the design, because when you buy an option, I told you, the option itself has got no meaning if there's no underlying for it. Option is just a contract written on something. What is that something? When you combine that something is underlying and the option itself, then there's a relationship between the two. Some special combination of the two instruments, that is the stock and its option contract, would provide a riskless portfolio. Okay? Riskless portfolio means what? There is no uncertainty about the value of the portfolio at the end of 3 months. Whether it goes up or it goes down, it must give you the same value. What I mean going up or going down is not the option itself going up or going down. It is the underlying asset value. In this case, the underlying asset is the stock. Only stock will have the price movements every day. The option is depends on that. Okay. Note that riskless profit portfolios are easy to price by using risk-free rate to discount the cash flows. We have been doing that all the time, and we assume that is continuously compounding. Then we can derive the value of the option accordingly for today's value. When you can calculate the value for 3 months' time, you already got it. In 3 months' time, it's going to be this kind of a price minus this kind of a K. The value, intrinsic value, positive intrinsic value is so much. That is after 3 months. But you're going to calculate what is the value today. So it's very simple. Use risk-free rate to discount it back to today. That's it. Okay. Now, there are 3 steps here. Setting up a riskless portfolio. When we say a portfolio is a combination of at least 2 instruments. So we have got the shares as the underlying and the option as the derivative. So consider the portfolio where you long delta number of shares and you short one call option. You are selling one call option. At the same time, you are buying delta number of shares. So, assuming going back to our original example value, if it goes up, it becomes 22 times delta. Why? Because that $22 depends on number of stocks. Minus $1 is the value. Okay. If it goes down, it is $18 price of number of stocks also, delta. So the portfolio is riskless when you combine these two to be equal. That's what we are talking about, riskless. When it goes up or goes down, you should be having equal value. So here, when you say 22 delta minus 1 should be equal to 18 delta, then it's very easy to identify what is the value of this delta variable. Okay, the delta itself is what? Nothing else other than 0.25. When you calculate this carefully, you see when you bring the 18 this side, it is 22 minus 18 is 4. 4 plus 1 is 5. Okay, when you divide it and see, it is 0.25, right? So the delta itself is 0.25. Now we plug in the delta value into the equation. That's step 2. Price the riskless portfolio. Assuming that the risk-free rate is given as 12% per annum for 1 year, and you are talking about 3 months. Well, let us see the timing there. The T is going to be 0.25. The riskless portfolio is to long the delta shares, that is 0.25 shares. So you see, we are already substituting the delta with the value which we found as to be 0.25 and short one call option. The value of the portfolio in 3 months should be what? $22 up times 0.25 delta minus 1 should be equals to 4.5. Same here, 18 times 0.25 is also 4.50. It satisfies the parity here. The value of the riskless portfolio today is on. You are just discounting back the 450, what it was in the 3 months to now. So there is 4.5 e to the power of minus 0.12, the 12%, times 0.25 is the time. So equals to 4.3670. That is the value of the portfolio today. It's not the value of the derivative call option. Let us calculate slowly what is the value of the call option. Okay. So far so good. Okay. Third step is the derive the option value. What you calculated earlier is you don't mistaken here, is the portfolio value. The riskless portfolio value is 4.367. What is the value of this call option? The portfolio, that is to long 0.25 shares and short one call option, is worth 4.367, which is 0.25 spot minus call, small call price. So the value of the shares today, shares in 3 months is for today it is $20. 0.25 times 20 is supposed to be 5. The value of the option is therefore very simple. The call option, the K is the small c, is 0.25 times S today, that is 20, minus 4.367 equals to $5 minus 4.367. You are minusing the 4.367 both sides. Is equals to 0.633. Remember this number. Even in the next method, the approach where risk neutral approach, you're going to see the same values, 0.633 for this same example. Okay. So the price of the option itself, or the premium of the option right now, is 0.633. Slowly you see these 3 steps. Let us look at back. Step 1 is to construct the riskless portfolio. You must have this carefully structured. Up is 22. How many number of shares? Minus 1 is the value. down is 18 delta. So these two must give you equal opportunity, no arbitrage. So therefore you can calculate what is the delta value. Once you calculate the delta value, price the riskless portfolio, not the option itself. Riskless portfolio that you have given, we have got a risk-free interest rate here, 12% per annum, and you are talking about 3 months, and you already got the delta value 0.25, and you short for one call option. So the value of the portfolio in 3 months is, you just substitute the 0.25 into the value of 22 now. In 3 months' time, it's going to become 22. Minus 1 equals to 4.5, or down it will be 18 times 0.25. It must satisfy. You see, both sides it comes 4.5. So the value of the riskless portfolio today itself is, just by discounting the 4.5 to now, that is a continuously compounding kind of a discounting thing here. That's why I use the minus 0.12 times 0.25. So you got it as 4.3670. Don't mistaken these as the premium. This is the portfolio value, riskless portfolio value. Now, step 3 is where you're going to derive the option value. In this case, you are shorting one call option. The portfolio is, that is, long 0.25 shares and short one call option. Remember back this. Always it depends on that. It's worth in 3 months' time as 4.367, which is actually 0.25 as up there is $22 minus the call premium. So now when you want to check it out as what is the price today, is 0.25 times S0, that is 20, should equals to 5. Naturally, quarter of 20 is 5. So substituting that 5 here as the value of the option itself, therefore, it is 0.25 times 20 minus the portfolio value which you calculated earlier, that's minus 4.367, should equals to 5 minus 4.367, which is equals to 0.633. So you got the value of this call option, which you're going to sell as 0.633 or 63.3 cents. Okay. Are you all clear about it until now? Okay, let us continue. Okay, generalization for binomial option pricing. These are the general functions which you have to understand first before we can move into other models. Okay, very important is what is the expiration time. A derivative lasts for a time t and is dependent on the underlying, that is a stock. So the price of the underlying stock is what will determine the moneyness of the option. Okay, the value of the option very much dependent on the stock price itself. So it all starts from the S0 today. What is the price today of the share? That is where we're going to find the price. See, S0 price is the stock price. What we are saying is F here, the small f here, is the price of the option itself, premium of the option. So as I told you, there are only two possibilities which we're going to take into account of this binomial. That's why we call it binomial, two nomial. That is the possibilities of going up to S0U or possibility of it coming down to S0 down. So if it's a call option, there'll be a value for up function. There won't be any value for down function if it's a call option. If it's a put option, then there is no value for the up function. There will be a value for the down function. That's how it moves. Let us see, putting in the values better. Consider the portfolio which you created earlier. There's long delta number of shares and short one option derivative. So the value is S0 up times the delta, that was 0.25 earlier, minus the function of the difference, the value. SD times delta shares minus FD. That's how it is working. The portfolio is riskless. So therefore, you can have the function like this, which is both the side it has to be equally holding the parity, that S0 up delta minus up function minus it should be equal to S0 down function of delta numbers minus FD, that's down function. Or you can rearrange it to have the delta value here, that is function up minus function down divided by price of up minus price of down. Let us see this by putting in some figures. Okay, the generalization of this portfolio at time t is S0 up function delta minus up function here. Okay, now the value of the portfolio today is what you're going to discount the whole thing here. That's E power of minus RT. So another expression of this value can be said as S0 number of delta minus the value F, whether it's up or down. Hence, you can rearrange the value of the portfolio itself is S0 delta minus S0 up delta minus up function. Discount it now because what you are calculating here, S0 up function delta minus up function is 3 months later or the expiry. You are trying to compare it with the current S0. That's why you have to discount it. Bring it to present value. So substituting for the delta you found just now, that is delta equals to up function minus down function divided by up price minus down price. So we obtained how to calculate the function of the value itself. This small f is the value which we are trying to look for at every expiry point, starting point, and at the expiry point if it's a one period binomial. So it is here we are bringing in as the probability of the up function plus probability of the down function is usually 1 minus p, okay, and discount it, exponential to power of minus RT. So basically you can rearrange that. This is how you can calculate the probability. Once you calculate the probability already, then the probability up is this, the probability down will be 1 minus this p. So it's actually just e to the power of RT, the compounding of it, minus the down function. Just now you saw the down was 0.9 because it was 18 divided by 20. The up function is 1.1 divided by up function 1.1 minus 0.9, the down function. Okay, we will see with some figures in the tutorial. Okay, that is how you calculate for the no arbitrage model. Now, we make the assumptions for risk neutral valuation approach. This is the second approach. Be careful about it. Earlier was the first approach, that is no arbitrage approach. Now we are going for risk neutral valuation approach. In the exams, I may ask you to calculate the same thing in two ways. The workings has got marks. We make the assumptions that the investor is risk neutral. What do you mean by risk neutral? Riskless. There is virtually no risk. Riskless means it's a risk-free situation. A risk-neutral investor does not increase the expected return they require from an investment to compensate the increased risk. So the function of high risk, high return doesn't work here because there is no high risk. A world where investors are risk neutral is referred as risk neutral world. And the risk neutral world has two features that simplify the pricing of derivatives. That is, the expected return on the underlying asset is risk-free rate. The expected return is always just the risk-free rate given for a period, maybe 3 months, for a 3-month expiring what we call option. The discount rate used for the expected payoff on the derivative is also risk-free rate. So the risk neutral valuation principle states that it is valid to assume the world is risk neutral when pricing options. The resulting option prices are correct not to just in the risk neutral world, but also in the real world. We can adopt it to the real world also. We started off as a replication in the risk neutral world, but we can use the same approach in the real world also.